So now in this lecture I am going to solve another problem. The problem is that only matrix which commutes with all the three Pauli matrices is a scalar matrix, and no matrix exists which anti-commute with all the three Pauli matrices. So let us try to solve this problem. It contains, or it's split into two parts. One is basically the scalar matrix, and that scalar matrix commutes with all the Pauli matrices. And second part contains that no matrix anti-commute with all the three Pauli matrices. So to prove this or to solve this problem, let us proceed as follows. So let alpha be a scalar matrix. Matrix of order 2, that is alpha can be written as A00A. Now let us try to find out commutator of this scalar matrix with sigma 1. Its commutator can be represented like this, and here this sigma 1 is equal to a polymatrix. So it can be written as A00A 0110 minus A00A, and sorry, not like this, but this term will be there, and A00A. And if I try to solve it, then after doing little simplification, it will become like this. And both are identical, that's why its value will be 0. Similarly, for sigma 2 is equal to, and sigma 2 is nothing but 0 minus iota 0. For this, let us try to solve another commutator, that is alpha sigma 2, and this can be expressed as alpha sigma 2 minus sigma 2 alpha, and it is A00A. And let me put its value here. It is 0 iota, sorry, minus iota, it's iota and 0, minus 0 minus iota 0, it is A00A. And if I solve it, then it will become 0 minus iota A0 minus 0 minus iota A and iota A0, and both the matrices are identical and its value will be equal to 0. Similarly, for third Pauli matrix, that is sigma 3 is equal to, and this sigma 3 can be expressed as this is 1 0 0 minus 1. So for this alpha sigma 3, its commutator is equal to alpha sigma 3 minus sigma 3 alpha, and the value of alpha will be A00A and 1 0 0 minus 1 minus, and it is 1 0 0 minus 1, here it is A00A. And if I solve this, then this is again A00 minus A and A00 minus A, and both are identical and its value will be again equal to 0. Thus, scalar matrix commute with all Pauli matrices. anticommute with all Pauli matrices. That's all. And now I want to take second part of this problem. In the second part, we want to show that there is no 2 by 2 matrix. There is no 2 by 2 matrix that anti-commute with Pauli matrices. So consider a matrix A and say its elements are A1, A2, A3 and A4. And this is not equal to 0. And let us assume that all A1, A2, A3 and A4 are not equal to 0. Means all are non-zero entities. That's what I am assuming. Now let me consider a anti-commutator A comma sigma 1, and it is A sigma 1 plus sigma 1A, and if I put its values A1, A2, A3, A4, and the value of sigma 1 will be 0, 1, 1, 0 plus 0, 1, 1, 0. It is A1, A2, A3 and A4. And if I solve all these matrices, means multiply, then it is A2, A1, A4 and A3. And similarly, it is A3, A4, A1 and A2, and this after simplification will become A2 plus A3, A1 plus A4, A4 plus A1 and A3 plus A2, and this matrix is non-zero as we have assumed that all are non-zero entities. Similarly, for the second part, I will start with the A sigma 2, its anti-commutator, and its anti-commutator is A1, A2 and A3, A4, and it is 0 minus iota, iota and 0 plus 0 minus iota, iota and 0, A1, A2, A3 and A4. It's a negative, right? And it's also negative. So if we solve with this, then this can be written as like this. This is equal to iota A2 minus iota A1. It is iota A4. It is minus iota A3 plus minus iota A3 minus iota A4, and it is iota A1 and it is iota A2, and this is equal to iota A2 minus A3 minus iota A1 plus A4, and it is iota A4 plus A1 and it is iota A2 minus A3, and this matrix is also not equal to 0. This is also non-zero, and similarly we can prove that A sigma 3, its anti-commutator, is also non-zero. Thus I conclude that there is no 2 by 2 matrix that anti-commute with Pauli matrices, right? So that's all, and in the next lecture I will try to solve another more problems on quantum mechanics. Thanks for watching this.